Hi everyone, and welcome to another session of Universal Filter. So for those who don't know, this universal filter is a theory that I recently came up with after reading texts on non-local consciousness. Basically, it is the belief that consciousness can exist beyond the body and has been exemplified by anecdotes of near-death experiences where people have an increased sense of awareness even though their brain is clinically dead, and they're able to hear, to sense things around that's happening, which corroborates with what's really happening in real life. So this led me to think that maybe there's another kind of input stream that we have that could be beyond the five senses. And so with that, I thought of this idea, universal filter, where basically you can use your intents and your thoughts to determine what input stream you want to tune into. So basically, the brain is some kind of antenna that helps you to select streams that you want, and you can learn from this limited input streams. So just a recap of what happened in the past, like if you do your intent and you focus on a particular input stream, like these words here, you can focus on like maybe the red words and you can make out hello instead of this jumble here, which you may not be able to understand. So there's quite a lot of practicalities to having a filter to filter your inputs so that you can learn from it. So this is a learning theory. And then we have things like universal information. We can filter it through our five senses and the non-physical senses as well. All right. Then we can also filter with intent. So with our intent, you can then focus on various parts of the image, like the lion on the right and so on, which will help to make more specificity in terms of what you are learning. And so we can also do things like time, right? Because the world we live in has time, and with time, you can then use this to query, hey, what happened in the past? What happened in the future? So what happened in the past could be something like in our memory, all right? Or it could be other things like if you believe in an energetic database, is the Akashic records, which records all the actions, past, present, and future of all conscious entities, right? Then we can also use this time as a way to do the filtering. So our senses filter things that are in the present, and we can use our memory to filter for things in the past. And so this filter is very, very versatile because you can select what you want to learn from, and you can focus on that to make very meaningful kind of deductions and learnings. So this is what we covered through in the past. And I was saying that time is even better in AI because in AI, you can have even better accuracy at getting you can have better accuracy at getting what you learn, okay? Because AI uses like atomic clocks, while the rest of our body, like we use circadian rhythms, which may not be very accurate in terms of how we get time, right? So if we want to analyze past memories and so on, actually AI has the advantage over human memory because we can remember things clearer in AI sense. You don't really have information loss. And in human memory, you have like fuzzy recall because sometimes things of the same location get stored together and you will have some messy recall. The AI systems, you don't get that. So I'm not sure whether the human memory or AI memory is superior, but both have their pros and cons. But this will be what is different in AI systems if you program. They will have very accurate time filters and they will have very accurate content filters because you can store things losslessly. All right, so let's move on to what we have for today. So with that in mind, all right, in the past I've been talking about abstraction spaces, memory spaces, where in the art challenge where you have a grid of pixels, like you want to find out like, okay, maybe this pixel here, you have a red pixel here, and you want to shift the red pixel to the right. So given an input grid, you want to know the output grid like that. So what I recommended in the past is that we have different kinds of abstraction spaces to solve problems. So like, for example, in this problem here, pixel level would be good. You can find out the XY coordinate of this, XY coordinate of this, and you can know that, oh, based on the examples, you shift one coordinate to the right. There are some tasks that are more object level. So for example, if your task is about like one red block here, and then the red block here, you need to, maybe by gravity go down all the way to the bottom. Yep, so this one you don't analyze more at the pixel level, you analyze at the object level. So you have to know this is an object. Um, you can also know stuff like, whether you can extract out the background of the information or the foreground. Those are abstraction spaces that you can do information processing on. So in order to get these abstraction spaces, in the past, I was thinking, hey, maybe we had to do a human defined abstraction space. All right. Or maybe we have to learn it from scratch, from experience and observation. But now I'm thinking that, if you have intent as your filter, and like assuming you have a knowledge base of like past problems and so on, you could, even for the art challenge, you have your past knowledge. You could know that, oh, in the past, people use pixel change color, or like objects move. And then you could also have stuff like, objects comprised of similar color adjacent to one another, similar color cells adjacent to one another. So like all this could form some knowledge base that you have. So you don't really have to define your filters anymore, like hard define your filters anymore. You could have a list of knowledge here. And based on your list of knowledge, you try to see which applies to this problem here. And then, you can form an intent. So your intent could be like, find out what happened to the object. So like by putting this intent here, and like maybe you can just put like this whole thing as maybe an image input or grid input to your system, and just applying that intent to the input, be it image or text, you can get an output here that says that maybe like output is square of 4 red bricks 2 by 2 moves from maybe the coordinate 10 1 to 0 to 0 1, something like that. Yeah, so basically the main thing that you can get out of what you analyze from the image will be based on the filter or the intent that you apply to the observation stream. So basically, you don't even need to learn the observation mapping anymore. Simply use this intent, apply it to your data stream, because all these are done in universal information, which means that text, image, audio, all these are the same information stream. And I mean, in multimodal large language models, this is more or less happening already. Your embedding space can represent image, can represent text. All you need to do is to do some relevant pre and post processing. So we are getting quite near to where universal information is. Next, you just need to add in video, audio, which is like sound over time. I mean, audio is already sound over time, but longer stretches. Once you do all this, and you get a universal information that can like operate over time, and I would say that we can use this intent to query things of the past, of the present, and so on. Like this is going to happen. This is going to happen in AI. You are able to use a universal intent, apply it to your data stream, and get a response. And with this universal intent, it is very powerful because based on your past knowledge here, you can get an intent that is relevant to what you already know of the world. So your intent have to come from somewhere. It doesn't appear from thin air. It needs to come from some kind of experience you have in the world, or maybe some shared knowledge with some other people. Then you can form the relevant filter that you need to query that problem. And you get the answer. I mean, instead of having only one intent like that, you could also have multiple intents. You could have multiple filters, find out what happened to the pixel. So in the art challenge way that I've coded in the LLMs as a mixture of multiple expert agents paper that I wrote, all these are done like hard coded, pixel object level. All these are done hard coded, but I can see that you can do this automated in the way that you ask the large language model to, based on some past knowledge, come up with some relevant filters to apply, or what I used to call abstraction spaces. Apply those abstraction spaces based on the intent of filters to your observation stream. So this is your observation stream. And you can get at the end will be an intent filtered observation stream. Okay, so this is huge. Okay, this is huge because what used to be a multi-dimensional observation stream will now be streamlined into something that is very, very focused as to what you really want based on your intent. So all this, what I'm saying now, is not just imagination. You can do this right now with large language models already. You just take your intent, like, summarize. Then you have a list of text here. Like, this is your observation stream, the text. A man walked into a bar and blah, 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 blah. And, the summary could be, there was a man in a bar. Yeah, so you could do this, and based on the intent, you can get like one thing, a summary. Another intent for this text could be extract entities. You apply this to your observation stream, which is in this case just text. All right, and you can get the entities like this. Man, bar. Those kind of stuff are already possible with large language models, which means this universal filter can be already done with current technology. So I'm not talking about the future here. This is present. It's just that, like, when we talk about true multimodal with audio, image, video, those might be a little tougher because the large language models may not be like available fully. Like, we are still constrained by some APIs through Gemini or OpenAI. But I'm sure that we have already found a way to map all these modalities into some embedding space, which means that you can use intent to filter it as well. So once we can get the filters out from this, you can learn from this. So you don't learn from this entire text itself because it's too much information here. I mean, here I didn't fill in the text, but it could be like a 50-page document. It's too much to learn from there, like too much information. Like, when you learn a new subject, you also don't learn from the entire textbook at one go, right? Like, you need to dissect, digest some information, gain some knowledge first, and use it for the next part. Like for math, you need to learn addition first before you can do multiplication, because multiplication requires addition, So you need to digest in part, learn something here, and then, like, this part here could go back, into your knowledge base. So later I have a diagram illustrating this, how to do universal filters and learning. So you have a knowledge base here. From this knowledge base, you can get new intents here, new intents, then you can analyze the information stream or observation stream. You get your resultant information that is filtered based on your intent, and you learn from that, go to your knowledge base again. So this is the learning cycle. All right. So not just for observation streams, you can also use this kind of filters to query your memory. All right. So, like, what you store in the past, you can store procedural memory, how to do stuff like motor actions and so on. You can store semantic memory, which is like facts about the world, like Tom is a boy, Mary is a girl, that kind of stuff. Episodic memory is like you can recall what happened in a particular episode, like how you used to walk to school and so on. All this because memory is basically, you saw earlier, is like all your input senses, five senses, non-physical senses, and so on, all consolidated together. And you just need to query a specific part of that memory, like, hey, what did I smell at the garden yesterday? Then you can get that memory back. But is memory really stored as procedural, semantic, episodic? I don't think so. I mean, it's stored basically based on your input. If your input is motor actions, then the memory will be muscle memory. So, like, this procedural memory is done in the body level. How you play the piano, how you walk, all these are trained over time, and you get more and more proficient at it because your body actually stores how to interpret and intend and carry out to motor actions. And as the neural network weights get strengthened, or rather your synapses grow, your neurons get kind of, you learn from the input output connection, you basically form new connections, new pathways, strengthen existing pathways. You will get better and better at doing a certain task, like playing a piano piece, right? So all these things can be queried also. So you can just query, play me Mozart Symphony number 1 or something. I'm just making it up. I mean, play me a tune X. Then based on what you have done before, you could associate that with relevant motor actions, and there you go, you can play your piece. Or like if you're a tennis player, you could just say, I want to return the serve. With that intent, when the ball comes, even though it's like, below your awareness threshold, like sometimes the ball is so fast you can't consciously process it, your body processes it and just returns it without conscious effort. Yeah, so that is procedural memory, and you can query it. Yeah, you can query procedural memory. You can query episodic memory. Very easy to query episodic memory. You just think, what was the last meal I ate? Yeah, so something like that you can query. Oh, then you're like, oh yeah, last night or this morning I ate this. So you can query what happened in the past by just thinking of a particular filter that you want to apply, or like you can query when was the last time I drank water. Yeah, so there's no specific way of storing it. You don't store like, hey, I store all the memories of drinking water somewhere in one database. Hey, I store all the memories of me eating a hamburger in another database. I store all the memories of me walking to school in another database. No, 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 no. We don't have so many databases. We just have one main database, the universal memory, or actually the universal memory and universal information. They are pretty much the same thing, all right? Because the universal memory is just a stock account of what has happened, of what you interpret from universal information. So like what you know stores in universal memory, or if you're talking about Akashic records, what people have done so far will be stored in universal memory, and not just what we people have done, or what conscious entities have done, what conscious entities are going to do in the future, the multiple possibilities, they are also stored in this universal memory. So it depends on what scale you're talking about. You're talking about individual memories, then it's what we have experienced with the five senses and the non-physical senses. You store all this, and with that, you can do querying with different filters. You learn the filters based on your past knowledge, and based on what you get from the filters, you can use this to consolidate back to your past knowledge. Okay, so I've covered quite a bit here. Do you have anything you want to talk about before I move on to the next slide? Yeah, this is a very important slide. Yeah, this is literally the main gist of the learning theory with universal filters. Yeah, I'll pause here for a while if you have anything you want to ask. Okay, so we move on, right? I take it that is clear. Okay, so this is the very important question now. Like, how can we apply these filters to filter what we have learned, what observation stream we have? How do we filter the universal information? And one way to do it is to do some form of mathematical operation on universal information. Like, for example, if your universal information is like X, maybe, like what you do is like, you can do like Y equals to WX plus B. Like this is like a linear transformation, which is like, you can treat this like linear layers in a transformer network, or like neural network. Okay, so of course there's also a sigmoid, maybe sigmoid or non-linear function. I just call it sigma, right? Sigma is the non-linear function. So like you can also do a non-linear transformation like this, right? So many possible ways of doing this mathematical transformation. So a filter, like for example, if the filter is trying to filter away the lower X values, you could just do like a step function. So there's many ways to do this. So like, let's say you have, if this is your universal information as a sine wave, you want to only take in inputs from this point, you can just do a multiplication with a step function like that. And then what you get is you get only the wave here. Yeah. So there are ways to do this. How you do this is not too important to me, but this is just how you can apply your intent. So in this case, in the mathematical notation, your intent could be a mathematical function, mathematical operation to apply to universal information. So this is the math view of it. Okay, it's a little limited in the sense that it's restricted to math, right? You can also do in terms of a broader way. You can talk about language prompts, like you can do an instruction prompt to an LM. You can say that, hey, my prompt is to filter even numbers. This is my observation stream, my data. I want to get back in numbers. And your response can be 246. And this is what I key into GPT-4o Mini. So you can actually do this right now with an LM. If you look at my strict JSON package, which is like a LM parsing package, you can do this filtering by specifying the output format you want. So like based on the output format you want from your LLM, you can say I want just even numbers, put them in a list. Yeah, so this essentially, this universal filter thing to do filtering is evident in LLM parsing, because in parsing, you are actually filtering. You are filtering out maybe the entities, you are filtering out the summaries. In fact, you are doing a chain of thought, you are filtering out the thoughts and the action. Yeah, observation, thoughts, actions. Observation is not from the filter, observation is from the observation stream. But the thoughts and your actions in your chain of thought framework, they are part of the filters that you apply in order to get information from the observation data, right? So these are all things that you can use to get your data. Well, you can also do an algorithmic operation. Like for example, you could say that, hey, let's say my universal information is a dictionary like this, I can say I want to query entity one like that, and I can get information on it. So it can be code. So the way that we represent universal information can be multiple things, depends on the level of information you are encoding. So if you're talking about the information of different entities joined together, and you don't want to interfere with one another, you can put them in dictionary. Or I mean, if you talk more mathematically, you can even do a Fourier kind of transformation on it. Or not really Fourier, like frequency modulated signals, or time modulated signals, like this. If basically you can represent all this entity one and entity two with different frequencies, and then once you multiply the frequencies together, you can get an entire band of signals. And then once you just do some frequency layer filtering, you can get back your individual data streams. So yeah, this one all in communications theory. You have some examples of this. So universal information could be a mesh of various frequencies all joined together. Maybe each individual has a unique code. Like for example, individual one, maybe frequency 300.1, individual two, maybe. So you have a unique address. Okay, maybe I use email address better. Like email address might be a better analogy. So like instead of doing frequency one, we could do like indiv1@gmail.com. Or like, okay, maybe we don't use Gmail. Okay, we don't associate with Google. indiv1@universal.com. All right, and then here we have. Yeah, I mean, actually, if you think of it, you can be an API query also. Like, you just query this database and you say, hey, I want to get indiv1's data, like a database query. You can get all the data from it. Like SQL query also might be also related to this idea of filtering. You could do that. Or you could do it totally based on math and frequencies, and you just apply some frequency filters to sample out the various frequency bands, right? So you have different frequencies here, and then if you talk about like all these individuals together, their frequencies will will they will all be stored separately at different unique addresses, and then the system will apply the interactions and so on to give you your next state and so on. But all these different perceptions of each individual, all this will be stored in separate email addresses. Then maybe if you have a like universal database, like to store all actions, store everything, it could be like all at universal.com. Right. So you don't just restrict yourself to what the individuals have observed. You could also query what the system has computed before and after. Yeah. I mean, you can treat it as sending a query to some email, pinging some API, I don't know, filtering some dictionary. There's many analogies for it. The exact format doesn't really matter. What just matters is that if you want to query something, you can get it back. So that's the main thing. So you can query something like a math operation, you can get back the waveform. That's one kind of query. Query by text, you get back another text. or multimodal query and get back multimodal response. So that's another kind of query. Or you send an API to some um, device to get back the response. That's also another query. Uh, so all these are equally valid. Okay. But if you want to do some learning in terms of like self-learning how the filters work and so on, maybe the best way to do it is still by embeddings, like because right now we have a way to learn might be more learnable with current architectures. Because like if you talk about like querying a waveform, querying like a language input output, like you may not be able to learn new things from it if it's not already present in what's existing in the knowledge base. Okay, so maybe if we talk about large language model architecture, we might be more inclined to do something like an LM token thing because this is currently what works. And I mean, in the future, we might think of something better. And I'm not restricted to just token-based learning. Yeah, I'm just saying that this kind of ways to query universal information are what can presently be done. All right. And I mean, it makes a lot of sense to just choose the one that makes the most sense for the kind of information you are programming in your system. I guess if your system is just like a database of individuals sleeping and awake, that kind of stuff, you don't really need vector embeddings, right? You can just use a dictionary like this with some enum of your states, where your states are all already fixed, distinct categories. But if let's say you're doing something more complex, your states can be a string of words that have no fixed number of categories. Maybe you need to use a large language model. So it all depends on the use case you have. Just go with the simplest one possible, because this universal information, if you want to model at the most universal level, it will be very complex. You saw the diagram in the past. Universal information is there's no end to it. Okay, universal information has infinitely many dimensions because you will always be able to represent something in even finer detail from the current level that you perceive it. So, an example is the atom. So, like for example, molecules, you go into atoms. You thought that's the end. Atoms you can go inside, you can see the quarks. After quarks, you go in, you can see the spins and of the subatomic particles, quantum particles. There's many more. I can't remember what are the spins up, down. There's a few in quantum theory. So there's a lot of things that you can see even within the quantum particles itself. Maybe you can even see further. Okay, so all these things, what we can measure and what is known in the universe, like what is modeled in the universe, are vastly different. We can only observe so little of what is actually out there. All right, so there's really too many dimensions to model. And if you want to do something that is more practical, you just model your lowest common denominator. Like if you're talking about modeling a system that people are sleeping and awake, you don't have to model infinite dimensions. You just model two, sleeping and awake. Yeah, and that's enough. Yeah. So yeah, these are just some practical tips on how we can implement the filtering to this universal information. And the filtering that I'm most inclined to do, and I think this is something that we can learn from, is multimodal tokens, because this is in multimodal LMs. So far, I think this has given quite good learnings, like quite good applications. We can talk about like we want to generate an image from some text prompt, or generate a video from some text prompt, and all this they use tokens to do some conditioning of the output, and it shows that the tokens are quite a good way to represent universal information, because it translates across modalities, and these tokens are done using vector embeddings right now. So like each token is given a vector embedding like this, and so on. So there's a lot of beauty with doing this kind of embeddings like this. Most notably is that it's trainable by the most common deep learning algorithm right now. You know what was it? Back propagation. So if you do it in terms of numbers, you can use back propagation. So Well, the actual universe may not do this, because I don't think math is actually, math may not be the lowest common denominator to represent our world, because, math itself has limitations. Like, you cannot perceive infinity with math. Like, infinity is something beyond what can be modeled, right? So there's a lot of things that are not possible because of the limitations of our knowledge base in mathematics. Okay? But at least in the idea of getting representations, this kind of n-dimensional vectors seem to be able to do quite a good job. And so I would say that a good starting point to model universal information right now is to use vector embeddings, right? So at least this is what I think. Okay, anything to add so far? Or all good? Okay, all good. All right, let's move on. Okay, so now we come to the most important thing. How do we learn these filters? And to learn the filters essentially is what I've described earlier, but now I have some slides to more concretely illustrate this. So how do we learn these filters? Okay, firstly, the filters have to come from somewhere, right? The intent has to come from somewhere. You don't just plug intent from thin air and say that, hey, paint me a dragon with three heads, that how do you know what's a dragon? How do you know what's three heads? This has to come from somewhere. You must have seen what's the meaning of a dragon in the past. You must have seen what's the meaning of a head, and you must know how to count three. What's the meaning of the number three. So if you know nothing of each of them, then the intent doesn't make sense, because you cannot query something you don't know. All right. You may not know the outcome of the query, but your query itself must be known to you. Okay, so take for example, like learning, all right? If let's say you are learning how to do something, like learning how to do math. Okay, so you want to query, like, how do I multiply, 3 34 by 34, that kind of thing. You can't query like this right now to your mind, because in order to do multiplication, you need to know how to do addition. So if you query like this and you don't know how to do addition, this query here, unless you can memorize a multiplication table and get the answer, this doesn't really make sense, because you need to be able to split down this problem in order to do the addition. So it's like 34 times 34. You need to know how to, and maybe it's better if I draw it out rather than this. So if let's say you are doing something like 34 by 34, you need to know how to do this part first. Okay, after you finish this part, like 16 here, and then here become 13 here, you need to then do the next part here, which is like 4 times 3 is 12. Then you add 1 here, 3 times 3 is 10, 9 plus 10. So 1, 3, 6, 1, 0, 3, and then you add together 6, 6, 1, 1. Okay, I'm not sure whether I calculated correctly, but this is the kind of thing that you will need to do in order to do the multiplication. So if you want to do this, you kind of need to know how to do addition first, because, you know, so basically when you query this, okay, you need to know essentially this query is split down into two parts. How do I do, okay, 34 by 34 by 4, and how do I do 34 by 30, and then how do I add the results out. Yeah, so then after that, this query can be split into even a lower denomination, where when you do how do I do 34 by 4 is the same as saying how do I do 30 by 4, how do I do 4 by 4, and how do I add this up. So can you see a very, very interesting thing here? Although the filter itself at a high level is like, how do I multiply this, right? Essentially, when you process your query, you process it in a task to subtask manner. So you have a task, your main intent, and you split into like sub-intents, or like some people will say task, subtask, goals, sub-goals. So all these things, each and every one of your subtasks and your sub-goals must be in your knowledge base. Okay, you will never be able to do this task if any of the steps are something outside of your knowledge. Okay, of course, this is what I'm talking about. Like, you are using this to query your own systems, right? Your own memory systems and so on. I mean, granted, if you offload this to a calculator, you need not know any of this. You can just use a calculator to get your answer. So you don't need to know addition. You don't need to know multiplication. You just, okay, maybe you need to know what this symbol is, multiply, but you don't even need to know what exactly constitutes a multiplication if you offload this whole thing to something else. So like in the agent Joe architecture, I call this an inner agent. You can do something like this so that the main system doesn't need to have the knowledge of the intricacies to calculate your multiplication. So you can entirely do this. So your thing is, if you want to do this without knowing the steps here, your knowledge base needs to contain the tool or the calculator and so on, if you want to proceed with this shortcut step here. So recently there's been a study about ChatGPT usage and the brain activations, right? So with ChatGPT usage, the activation of the brain is very minimal compared to non-ChatGPT usage, which makes a lot of sense because like this part here of the tool is the ChatGPT usage. You see, you don't even need to know the details of how to do it. You just ask the calculator and the calculator gives you back. Whereas if you want to do it yourself, you need to know all the steps. You need to know how to count stuff. And that takes up a lot more steps of processing. And this means that, you need to use more effort to do it. So, I mean, the results make sense to me. But you also learn more if you do this as compared to ask a tool like this. Okay, because the tool can give you the answer, but you have no idea how the answer came about. Okay, unless the tool gives you the steps as well. So that's why a lot of learning systems like Khan Academy and so on, when they ask AI to do stuff, the AI also will guide you how to do the steps. Hopefully, it helps you to go towards this right side here, where you know the steps and so on to learn those ideas, sub steps and so on. And if you want to do this right pathway, this is the right pathway is like do it yourself. You can hopefully with usage of tools, you can approximate the right pathway as well. But it's different. You still need to do it yourself if you want to know how to do it properly. So yes, all this means that if you want to have a filter, you need to know the constituent parts of it. If not, your filter will have no meaning. Right? Anytime any of these parts here don't add up, you won't be able to do the filtering. Because how do you convey that message to the database you are querying? Like, how do I talk to you about X if I have no idea what X is? Like, I need to know what's the meaning of X. I need to know it in the sense that I need to be able to convey that message to you. Okay, even though I may not know exactly what X is, like in this case, I may not know what's multiply, but I need to know the term multiply. Okay, I need to know that multiply is a word that I send to a calculator and I get the answer. I need to know at least that part. If not, I can't I can't query the calculator. Right? I need to know that keyword like multiply, add, right? Or if you are talking about you are doing your own kind of things without tools, you need to know how to do the various steps, the concepts behind the various steps. And that's also how come learning is progressive, because you need to know the foundations first before you can utilize the foundations to get even higher learnings. So all these things are related to how we filter the observation space around us. Because if you don't learn that particular component of a filter, you will never be able to do more and more complex filters, right? The more complex your filters, the more you need to learn. It's as simple as that. That's learning theory. Like, you don't learn the foundations, you can't do the more advanced things. Like, if you don't do addition, you don't know addition, you can't do calculus. Right? Simple as that. Or you don't know multiplication, you can't do calculus. So that is example with math. I'm only using math because it's a bit more concrete. I mean, you can also do some other examples. Like, for example, you want to know how to navigate from point A to point B. Okay, can anyone tell me if, let's say, you want to know how to navigate from point A to point B, what must already be in your knowledge system for this query to work? Anyone can tell me what are the implicit knowledge that is needed for this query to work? Anyone?
Well, the location of point A, the location of point B, however you represent the location, and then you need a means of reasoning or algorithmically solving the trajectory and tracing the path between the 2 points. So, for example, A star or Dijkstra algorithm is how most programmers do it, uh, Google Maps, etc. Um, but I think it would be the three main things: the navigation algorithm, and then the locations of both points, so you could trace and do the math. So really, this whole question is it's basically a math problem. You have to convert the English into a mathematical formula and then solve for the answer, because that's all it is. You're just solving for the trajectory.
Yeah, that's a great answer. So essentially, the three things I circled: how to navigate, how to what's point A and what's point B. So all this must have some meaning for you. If not, you won't be able to query it. All right. So regardless how you navigate, Dijkstra algorithm, Floyd-Warshall, breadth first search, depth first search, or simply just drawing a straight line, or how you navigate is entirely up to your interpretation of navigate. Like, for example, if for some alien species navigation is teleportation, then all our algorithms make no sense to them, right? They will just say point A, point B, ting, I'm there. Right? Why do you need to do all these complicated algorithms? Space-time doesn't exist. Ting, I just appear there. Then it doesn't the knowledge behind navigate may not be the same as what they think of navigate. So again, different individuals might interpret the same word differently, but in order for your querying to be successful, your interpretation and the database you are querying must have the same kind of representation for all your interpretations. So your knowledge base, okay, should have same meaning for each of your query terms. Like you should already know. Okay, and just to make things a little complicated here, a language is not all there is that you can query. All right, we might think that we only think in terms of words and thoughts, words as in written prose and so on. Uh, a good deal of our thinking in our heads actually can be non-verbal. All right, it could be pictures, sounds. Yeah, all these things can also be used to query stuff. Anything that you have seen in your observation stream can be used to query as long as you store it somewhere. Yep. Or I mean, if you're querying a knowledge base, you as long as the format fits the knowledge base storage representation, you can query it using those means as well. So a lot of times people can think with pictures, like you can just imagine like your school and memories will flood in. Yeah. You can hear a piece of music, especially if that music is played during your wedding or some important occasion, memories of that will flood in. So there's many ways to query that is beyond just this kind of texting. But if you query with pictures and sounds and so on, you will need to ensure that you know what what you are querying is in your knowledge base. And also, and in the database knowledge base. Okay, because the querying only works if the receiver and the sender and the receiver have the same kind of understanding. If not, when you query something, you get back something different, right, from what you expect. So the thing is, we have various ways of querying, and here now we are just looking at the individual querying its own individual knowledge base, which also means that, okay, maybe knowledge base is the wrong word to use here, because knowledge base, I mean like what you already know. When you query this, maybe you talk about, oops, let's talk about a database, all right? Not knowledge base. Okay, knowledge base is like what was used to create these filters. Like in order to know the meaning navigate, to know the meaning point A, to know the meaning point B, we need some form of representation. And that is from your knowledge base, like how you have represented the knowledge, and you query a database here to get your answer. So this over here means that, whenever we do this filtering, the database will also need to have the same kind of knowledge base. So essentially, when we store things in the database, perhaps it's using the same kind of like way we interpret the world and we store that in the database. Or everything here is stored in universal information. So I quite like the universal information kind of point of view, because regardless of how you learn the filters and intent, your database can answer you. All right. So what will happen is that you will answer, the database will answer your filters here, which are converted to universal information. And your database will respond back in terms of universal information. And you will just use your filters and get back the representation based on universal information. So case in point is like this. Let me just delete everything. When you send a text message to an LM, like summarize the text, and then you have this text here. Essentially, you are representing some filters here, which will then be converted to universal information, which is maybe some embedding. The LM will receive this, convert back this thing to universal information as well. And then over here, what we do is we have the receive information. The summary is something, right? So over here, when we reply in universal information, the LM replies here, you have a way to convert back. Let me use a different color. Convert back information based on your filters. So in this case, like the next token prediction could be like, let's say we have this embedding space here. You send back to the individual would decipher it, like maybe using next token prediction and so on, to get back a representation of like what this LM has replied. So this LM here could be your database. Essentially, what we are viewing here right now in most modern AI systems is that your querying and your LM and the reply here, all these are in the same abstraction space, same embedding space, because when we query, we use the same token space as the LM. This is an assumption, and it's a very important one, because if not, there might be mismatch. What I'm saying is that there exists a universal embedding. Okay, let me put this here. Okay, a different color. There might exist a universal embedding where different users, different LMs can communicate based on this common embedding, right? And this universal embedding means that, if I have learned different things from you, I can still talk to you and you can still understand me. And the way we have done this is through language right now. Like the universal embedding is actually like how we talk to each other in English. You might learn from different corpus for one LM, but the answer will still be in English, right? So, or in some language, which you can use to copy and paste to another LM to continue the conversation. So in some sense, the universal information here could be, the way that we represent words and so on. And this will be interpreted like in pretty much the same way by, okay, I wouldn't say the same way. Let me think about this. Because words itself contains nuances that might be different based on different cultural context, different corpus that you use. So maybe the universal embedding here may be something even deeper than language. It's not the written word itself. It's the way you represent those words. So maybe I take that back, because words itself, can cause confusion sometimes. This universal embedding lies at a deeper layer than language. It's like once I tell you about something, some representation is formed, and this representation could be universal to every single one of us. It's just that it's very hard to get this universal thing without knowing exactly like where your information comes from. So if you want to know how to model this at a very, very deep layer, this universal embedding, a bit big thing for you, for people to digest, this must be trained on everything. Okay, because the only way for me to interpret your point of view and this point of view is that the universal information and the universal embedding itself, it needs to know all there is right now so that I can interpret your point of view. I can interpret it and I can change it. I can morph it to another person's point of view. So in some sense, if your LLM is trained on large enough data, it could be a universal embedding, all right? So when I say I want to translate English to Spanish or English to Mandarin or French to German, that kind of stuff, I might only know the French embedding space because that's my query, right? I query in French. But if your universal embedding is trained on everything, all languages and so on, it can translate the French to German for you and reply to you in German. And okay, based on your filters, you want to output based on German, okay? But you may not know a single word of what's being given back to you, okay? That's fine because you have said, I want to get back in German. So all these things here are new tokens that you get back. You may not know the meaning of these tokens, but you know these are information you get back. So yeah, I think talking to you, I've been a bit more clear on this. You may not need to understand what you get back. Okay, simply because you may not have the knowledge for it. But you can, as long as your query is within your knowledge bounds, you can get back things that are beyond your knowledge base. And it's up to you how you make sense of this random stream of tokens here. German tokens, if you don't understand German, it makes no sense to you at all. But it's perfectly fine to get it back. You can just translate French to German. Yeah, you know French, and then you can learn German based on it. Yeah, essentially all of learning is something like that. You don't know something, you ask a little bit, how are clouds formed? Then you get the data back. Oh, clouds are formed because of water vapor evaporating up and then condensation in the air and so on. You may not know what's condensation, you may not know what's evaporating. You can search what is evaporating. And evaporation is the process whereby water converts into, gaseous form and then goes up. Then after you can ask even more stuff to say, hey, what is gaseous? Then you can get those things. So the result is filtered back based on what you want it to be. So in this case, most of the filters are language, like English language. You come back as English language. They find out some terms that you don't understand. You find out more. What does it mean? Uh, how do I apply it? That is learning. So essentially, the only thing that you need is that your query is understandable by yourself. And of course, the database. But in this case, we are assuming that when we query something, like we query our knowledge base, when we query our knowledge base, when we query the database, this database itself could be your own memory. So in this case, the embedding space would be similar because you store what you can interpret based on your embedding space, right? But if you're talking about querying something that is beyond your individual memory, like for example, a large language model that contains a lot of information, you don't need to basically worry that it doesn't understand you because this LLM is supposed to be trained on everything. It will understand you. And then it will reply to you something that you may or may not understand, but that's fine because you can gain knowledge from investigating what is received. Right. So yeah, I'll leave it here. I hope this is clear. I'm still refining this theory as we talk, but I think what I talked about here, I'm quite keen on having a universal database right now because I think that makes a lot of sense. That you can understand different perspectives and reply to you based on your perspective. I think that's very important. Yeah. Okay. Yeah. Any questions or thoughts, comments?
So the database slash stream is well, let me see. No, because you said the universal information is going to be part of the stream and feed into the database, right? And the database is your internal knowledge, but it's not your knowledge base. which is the filters, correct? The what you've learned how to filter.
Knowledge base will be here. To come up with the filter, you need to come up with something that you yourself know in your knowledge base.
Got it. So the knowledge base is designed to convert the stream into something that's usable into your database, right?
Yeah, so the knowledge base is used to send a query to some system. The system will give you back the knowledge, and the knowledge you may or may not understand, but you just store this in your knowledge base. Like,
Oh, I got it. Okay. And I understand now. Okay. So the in the knowledge base, you said that the it had to be learned. So is the learning the intent-based learning and the filters you learn, is it relational based where if you're how do I describe it? If you run into something you don't know how to query, you have to relate it back to something you do understand how to query within your knowledge base and then go from there. Is that correct? It's kind of like you said, it's like axiomatic. So you kind of build up your learning over time as you train and learn more things about a query from your database using your knowledge base. So is your knowledge base basically relational learning? Is that kind of what you're getting at?
yes, you need to learn things based on how you already know how to interpret things. So based on what you have received back, you will kind of map it back to whatever knowledge you have, and then you will gain insight. So this process is not like one-way download. You still need to digest the information, map it to what you already know, form new semantic connections, and so on. So this is in the reflection phase. I'll talk about it later. Of course, if you don't do any reflection at all, you can just memorize the entire text and put it in your head, or memorize the entire, input stream, output stream, and put it in your knowledge base. But it'll be a very superficial knowledge. So, like, let's say if your knowledge base is like this, if your knowledge base is made of some nodes, connections with like different entities and relations like that, like knowledge graph maybe. But I mean, knowledge graph is very contrived because you can only store so much in the knowledge graph. But it's like some semantic mapping. You already have map of the world, and suddenly comes a German text that you have no idea what this is. So like you have a German text here. If you have managed to consolidate this German text well, it would appear in your semantic map as you know new branches of knowledge that can map to German. And this are like basically you have consolidated some meanings of some words. If not, what will happen is if you don't know those words that come back, your whole German text would just be stored somewhere in your semantic map here that has like not much connection. Maybe it has only one connection to like maybe your query. Your initial query is this, I get back this. So it's very contrived if you don't learn the inner meanings of what you have received back and map it back to your existing knowledge. It will just exist as, hey, I queried the database and I got this. But what's this? I have no clue. Okay, I just know I got back this. Yeah. So you will still learn something. You will learn that your query got back that result. But you won't digest the information into some better, semantic graph where you can learn better because you have consolidated the information within your existing knowledge. Yeah. So yeah, learning to me is about the second part where you need to consolidate in your existing knowledge because if not, you can't do more complex queries after that. If you just put into one single line here where you just connect with your query and get your response back, this is superficial learning. That's like what happens when you memorize by rote. You have no idea what you memorize, but you memorize it. Yeah. Okay. Yeah, Derek, you want to say something?
No, I'm not too much, but it ties back to the calculator that you were talking about, the agent use calculator. Um, so you can either have true understanding and you can tie it back to your knowledge base, which would basically be the step-by-step process where you can actually trace the trajectory of reasoning and you understand how you reached your end goal. Or you can just store it in your knowledge base as pure memory, have no understanding of it, but memorize it. So if any time you need to calculate something, you trigger the calculator, but you have no understanding of how the calculator functions or how it reaches its end goals. You only know how to trigger the calculator. So it's basically a trade-off. So you can either have a traceable reasoning what do you call it, trajectory via your knowledge base, or you can have a quicker memory base that doesn't have a trajectory added to it, so you can't interpret it as well or reason as well. Is that what I'm getting at?
Yes, yes. So basically, you can learn in two ways. One way is you
Okay.
learn very superficially, like what you said. You learn the tool output based on your tool query, or you can learn how to interpret the findings of what you have learned in a larger semantic web. Yeah. So actually, this is what is basically learning should be defined as the second one, because if you just learn how to get the tool use and the tool query, like you memorize that input output relation like that, you only know the input output relation. You wouldn't know something else. Like you wouldn't really learn how to use it in other situations. So yeah, I do think that you will learn something from any kind of observation you have. It's just whether that learning is more broad or is more specific in nature. And ideally, when we learn, we want to learn the broad nature, because yeah, specific nature stuff is very, very situation based. And you may not get that same situation all the time.
Gotcha. And last thing is for the universal embedding, um, the deeper layer, is that related to the latent space slash concept space? Okay, because you kind of said like you have to train on everything for both parties in order for them to kind of go back and forth, vice versa, and translate their ideas. Is that purely related to concept space slash latent space, or is it something deeper than just pure concepts and basically having the same knowledge base of concepts?
Yeah, I think it is important. It's beyond concepts and latent spaces. It's more like, in order to talk to every single person in the world, you need to know the history, the information of every single person in the world, which means that you need to form concepts, representations of them, of the words they use, of cultures, in fact, beyond words, images, audio. Like if you can train on all this information, you can form a knowledge base of the entire world, which ideally should be updated over time. And I also have this concept that sorry, wrong slide. I also have this concept that, like, this universal embedding could be based on the knowledge, the input stream of everyone. So like this is the input stream from every conscious entity. You can get this from everyone. You train on this, and then what will happen is that you form deeper relations between information, because you have the input stream from everyone. You can do association. Oh, scenario one, person that did action A got this result. Scenario two, person did action A got another result. You could get even some probability understanding of the outcomes and so on. Like, so the more input data you have, the better you are at forming relations, because you won't just see a small picture like how an experiment would view it. You see the entire picture. And of course, you could even say that if you are able to train on not just every conscious entity, you could train from every system interaction, which is basically like if you have a model of the entire world, even if no one perceives the stuff, you can also train on the own system interactions. That is even more powerful, but I'm not sure how feasible that is. But if you just think about like taking all the inputs from every single individual and learning from it, I think that may be already very good already for learning, because this means that you are able to get a lot of information from everyone. Everyone is a data collector. Feedback to this main universal knowledge. So like one way of doing universal knowledge, okay, is basically what we talked about last week. Where's my line? I want to draw a line. Give me a while. I want to draw. Okay, so basically you have one big thing here that is consolidated from all your entities. So like individual one will feed in information to this big cloud here. Information individual two will feed in information to another big cloud here, and so on. So like if you take in all these individuals and you consolidate all their experiences here, you can learn from, this is the consolidated observation streams from everyone. Yeah, you can basically learn from this and get what each individual may not be aware of, because each individual is aware of their own space. But it could be that if you look at 10 different spaces together, you can learn something even bigger. Like you can learn, oh, people who are in the North Pole are feeling cold. Then you can learn, okay, North Pole is cold. But for individual one who's only in the North Pole, they will never know what feeling warm might mean because like to them this is normal. So this consolidated information observation streams are important and not, I mean, if let's say you can even model the world, so it's like this is the system interaction of your world, and you can model like how the molecules bump each other and so on. Like this might even give you even more things. Like so, then the individuals can query what happens if if let's say a box rolls down the hill. Like maybe no one has seen a box roll down the hill, but if you can model that system interaction inside here, you can tell them if a box rolls down the hill, this will happen. Like there's some hypothetical scenarios that no one has observed before. Like if you could model system interaction here, you will get those data. Okay, but I think just in a very contrived sense, just taking the input from all the individuals' observations is already more powerful than just having one single individual's experiences in terms of this database that you're querying. Yeah, so I'm still thinking to what extent should we model this database? But based on what we see in current LLM trends, they just take the corpus of data online, which is more or less the observation streams from all the individuals. Okay, actually maybe not just individuals because online may also have AI bots and so on. So it's more than that. It's more than that. There's I mean unless you treat AI as individuals as well, which potentially we can do because AI itself makes actions and does things in the world, right? You can treat it as a conscious entity. Then sure, you take in all these observation streams from everyone, train on them, you can get a universal embedding. Yeah, that is beyond just concepts and so on. It's like experiences of everyone. Like it's huge. Like it's actually beyond what we have learned so far in LM embedding space because that is more or less the static embedding space of text, audio, images. This embedding space I'm thinking of is your life experiences, is video, episodic memories, and so on. That basically you can query every single person's life to the point that like, hey, what did that person do at age 5 at this school and so on? Like what happened? Like that is the kind of data that you have in this common stream here. Yeah, which you can then learn and earn universal information from.
So following your line of thought, if you are you saying that if you have enough dimensions in your embedding or in your vector, you can represent even the deepest layer of like abstraction or universality we're talking about here? Because I don't see how you would do it unless you had enough dimensions to represent every nuance or every possible quote unquote concept or idea within that deeper layer. Not like concept as a layer, but using the dimensions to represent each possible concept within your universal embedding.
So you're saying how we model nuances, like maybe some word like green may mean green number one to someone, it might mean brown to another person. Yeah.
Right,
Oh.
and each what do you call it, perturbation creates an extra dimension of like nuance that you have to account for when you're trying to create a embedding that represents every possible universal abstraction, I guess, or like
Mm,
possible idea. I'm trying to avoid saying concept. I don't know what else to say
don't
in this
worry, don't worry.
context.
This
But
is
you,
very, very like highly abstract because this is a
yeah.
hypothesis. This is not a fact. Yeah.
But you get what I'm trying to say. Like every time you create like a variation or perturbation to the kind of like the universal embedding and possibilities, every time you have to like kind of represent a different variation of what someone's experienced or what someone has done or how they have perceived the environment within the consolidated observation stream. You kind of have to create extra dimensions to account for that nuance and that
Yes, yes, yes. You're right. You're right.
representation.
Correct.
So you see how it becomes exponential, and now your universal embedding idea requires like a 1 billion qubit quantum computer just to calculate. So you kind of get my point. It's just like it's the idea is cool in theory. I just I guess I'm trying to say that maybe a better way to represent the universal embedding slash universal translation may be required to put the idea into effect as opposed to pure theory.
Mm. So, I mean, there's a few ways to solve the problem. Like, for example, if an individual one represents green as green number one, and individual two represents green as either green number two or like brown, what would happen is that the embedding for green doesn't change. Okay, this is still a universal embedding because it's the same color green, right? It's just this part here, this filtering part here, right? When it is passed back to individual filters, the meaning changes. Yeah, I mean, like in the universal information itself, you don't have to model green separately. Like green number one or brown is the same thing in universal embedding because it's the same observation. It's just once you pass back to the user, you pass back in terms of their filters.
Gotcha. So you don't try to store everything, you just try to store the trajectories. So you just store the green embedding or whatever, and then you let each individual filter it in their own way and have their own trajectories. Um, just so that you don't have to deal with storing everything everywhere all at once at the same time. You just let the embeddings get changed and translated over time as it changes hands from hands from the universal information down the filter pipeline to individuals.
Yeah, I believe so. So when we do a filter query, essentially we are querying the universal information with our own bias lens, which the universal information site would be able to interpret because it has observations from everyone. It knows how to think, oh, you're talking about green here, but actually you mean brown. So I give you back based on your lens of brown. And so basically this is something that is only possible if the universal information database knows everyone's knowledge base. So you know the knowledge base. Basically, it's something like context. Based on your context, I can say that, oh, you're telling me I want to find out the green objects. But then you can put a context prompt there saying the green is actually brown. Yeah, so it means that this individual's observations here, their knowledge base will need to be made known to this universal embedding here so that you can know when you send information to the universal embedding, it knows what you are talking about. It won't interpret based on your subjective lens. It will be interpreting based on a universal ground truth. And yeah, this is very powerful idea. This is a very powerful idea. It means that regardless of cultural bias, societal bias, and so on, the ground truth information you receive from the world is the same. Okay, it's just how you interpret it. So if a system is able to dissect how you interpret things in your mind and put them back into the universal ground truth, that is a huge win. Okay, then you can translate across cultures, across contexts, and so on. Right now we can do with a limited extent by words, yeah, but this is beyond words. This is more like you are able to represent everyone's thoughts and experiences in some consolidated database. And this is very, very powerful. You can do that. Then you can essentially know what it is like to live like another person. Like, how is it to be in someone's shoes, right? No problem. You can just query how is it like to be in person X shoes. And the universal information stream, like the LM will reply back, okay, you are now in this person's shoes, you observe this and that. Yeah, based on that person's way of viewing the world by their filters, their sense filters, their inner beliefs, all this can form a filter. Their emotions can form a filter as well. Like so all this you will be able to do universal communication and totally understand one another if this kind of system can be built. So I think when I talk about training on everything, you are talking about training on the subjective beliefs, but you are able to interpret them into objective um, observations, objective beliefs after, catering the knowledge base of each individual. Yeah. So how to build this? Still thinking about it, but I think the easiest way is that, you know, whenever you have an individual giving information about the world, it is best that the system itself also knows what is the ground truth observation the individual receives. Because, when the individual views something, the individual in the world actually receives a data stream. It'd be great if that data stream could be given to this universal information, the original data stream, and like the the interpretation of the user, or this how the user views things, they will be able to store it in their knowledge base, and this can form a filter and so on. So this filter is applied on the universal information to give you a more objective, a more subjective view of the world. From this subjective view, and given your subjective view and your knowledge base, I can remap back to the universal information. That's the way to do this, uh, like intent-based filters. Like if we have this database that can do this, you can essentially learn anything to the user's pace. The user can ask a question. I can, based on what you already know, I can give you back what you have, like what you should be able to understand based on this. Like it's quite powerful. Once you can do that, you have a very powerful learning tool that you can use to progressively learn based on what you already know. It sounds a bit vague here right now because it's a system that is so powerful it hasn't been invented yet. But it's a system that is able to understand your own personal biases and so on, and caters to your bias. Yeah, it's I don't know whether we can do it, but I mean this basically means converting information to universal information and passing it back through your filters to you. Yeah, and to learn this universal information, we take in information from all the individuals and even your system interaction and all the individuals' knowledge base.
No, I get exactly what you mean. You're talking about a very personalized interface, but it's like at a next level of personalization. The LLM, the data, well, I would describe this. The database is able to take your personal query and convert it through the interface. It allows you to interface with the universal stream at a personal level, basically. It's a very personal level of integration and interfacing with the world knowledge, kind of like the consolidated world knowledge bubble in this case. Um, but it's basically a personalized interface that allows you to have a very deep connection to the data source or the database in this context, because you can say exactly what you want and get back exactly what you wanted that you personally needed, and it won't be like some vague, vague answer, like a vague Google answer or whatever. It's a very personalized answer that's been converted back from the universal database.
Yes, I think you got it. Yeah, so one way to do this right now is to put context for like your biases inside the prompt. And then based on your filters, you can also put like, reply to me in this manner, like with this kind of assumptions or this kind of biases as well. You could mention that in your filter. You like for example, if you look at the previous example here, um you could give like, hey, okay, maybe my knowledge base is like, if this is my knowledge base, like this already is your own subjective knowledge because like this data here has been interpreted by you as numbers. All right, and I want to give back in terms of numbers as well. So this is the format the universal information needs to reply me in, and it can cater to me. Like this is the data stream that I have, and like my past experiences, maybe it could be like, my context could be like, numbers, single digits, so like these are some examples of stuff that I know in my knowledge base that led me to derive this prompt. And if we could put this as the input to your query, like your assumptions to your query, your filters, this will make your querying very, very powerful. Like for example, if you're talking about, what are the green objects in the picture? But for someone who is green brown colorblind, okay, I'm not sure whether that's green brown or green red colorblind, you can put as context, green is red in green is subjective, and I am like maybe green red colorblind. So these are like some stuff that are, maybe if you could model that into the filter itself, the universal information is able to take this and convert it to what are the red objects in the picture. Yeah. So essentially you get back information that is catered to your understanding. Because there's no point telling you the actual green objects if you don't see it as green. You will just say, hey, why is it giving me the wrong information? Like if I ask you, what is 1 plus 1, all right? And I have no idea that plus is actually minus, all right? So actually I wanted 1 minus 1, but I tell you what's 1 plus 1. But my own personal bias tells me that, no, plus is minus. So the answer I should be getting back is 0, all right? That's if you want to view it in your lens. And the universal information can view it in your lens as well. However, again, this is about learning philosophy. Maybe it might be more beneficial to convert the understanding of the individual to know what is 1 plus 1 as a plus instead of a minus. It's like saying that, oh, you've been treating a plus wrongly. It's actually addition, it's not subtraction. So 1 plus 1 is actually equals to 2. So your answer back to that individual could be like, hey, you have applied the wrong assumption to this your whole life. Maybe you should change it. Yeah. So still thinking about what is the better option. Because let's say for red-green colorblind, right? There's no point saying that, hey, what are the green objects in the picture? I give you back all the red objects. I give you back all the green objects that to you is not green. Like, no, then it's not like it doesn't really help what you want to find out. But if that person really, really wants to find out what are the really green objects in the picture, like based on the true definition of green, then it's a disservice to model their biases and return back their biases because you really want to know where the green is. Like take for example, objective biases here. The objective truth here, coding. If I want to find out the error in my code, I shouldn't be modeling my own personal bias inside the prompt itself because code is basically like whether it works or not, right? Whether I think it works doesn't really matter than whether it works. So you don't model personal bias here, you just test it out, give back the answer that actually works based on the compiler. So there are cases where you don't want any subjective interference at all. You want to just treat the information that the user provides as the total ground truth and work with it. Don't apply the personal filters at all. There are some cases like this. So when you query something like query your memory and so on, like query memory is okay because your memory has your own biases inside. Yeah, so that's fine. But if you are querying a universal database to get your answer, you know, how do you make sure that this database doesn't adhere to your kind of interpretation but give you back the ground truth? Or do you want the database to give you back based on your interpretation? Because maybe our interpretation is that we want to talk about green, and green appears green in our eyes, but to the universal information database, green is actually color number 5544. There's so many colors there. Green is just a small spectrum of their colors. And like you don't want to reply back green in terms of the understanding of green by the universal information, which is like maybe colors number 5000 to 6000 are green. You don't want that. The user might just be talking about color 5544. So you just want to reply back color 5544. So I do think that modeling bias is important for effective querying because essentially the queries that you give, the filters that you give are all based on your level of understanding of the world. Like you go back to here, you basically apply this filters to get the abstraction spaces, and you need to be able to know what your filters are. Where did I put that? You need to know what your filters are based on your knowledge bounds. So I think in this case, like whatever I filter, whatever I query the system, I want it to be back in the very subjective manner because that is your knowledge bounds. I need to respect your knowledge bounds and answer you based on what you know. But at the same time, there are some cases that are more objective, like coding. What you know doesn't matter. What is what works. So there are two ways to model the system. Okay, I think so sorry, I don't think I can finish the rest of the slides today, but I think this is a very interesting point to discuss. Maybe I open up to the floor. You can talk about should the universal information database respond back based on the subjective filters of the individual, or should it be more ground truth? Like I should just respond according to the ground truth that the universal information knows.
I think the question you're asking is actually pretty complicated. I mean, if I had to give a off the spot answer, I think I think what you're saying is subjectivity is a spectrum, that there's some subjectivity that's good that allows for diverse conclusions and diverse problem solving. Like the hobbies I enjoy and the hobbies you enjoy are going to be different because we have different backgrounds. And that's a good thing because we can both culture different experiences and then come together and do, stuff like this, discussions, and with different backgrounds and different ideas. And our subjectivity allows for more creative and more advanced, complex problem solving. And then that other side of the spectrum, like you're saying, is just objectivity, where you reach a threshold of being so far from the ground truth that hey, you just kick back and say, hey, you're just wrong, right? Like I get it. You really want to subtract, but you're just wrong. That's not how math works. Try again. So I get where you're coming from, but I think what you're asking is how do we define the gradients of the spectrum of subjectivity and objectivity? And that's very complicated, and it gets exponentially complicated when you go beyond like 10 people. And you're talking about like 7 billion or 8 billion people, I think, like a
More than
worldwide.
that, if we talk about all conscious entities, it includes animals, plants, and so on. All this
That's
knowledge can be represented in universal information as well. Yeah, not
that's
just pure
just
knowledge.
that's just so complicated. I feel like we should just build the learning system and just give the task of figuring it out for us because I don't want to do that. That's complicated, man. I would rather build a learning system that could figure it out for us and then get back to us and tell us, hey, what did you figure out based on everything you learned and all the data we fed you? I don't know if I could figure that out. I don't really have an answer.
Yeah, actually, I think based on your answer, I got some insights. I feel like the level of subjectivity that you give the user's query might be an input to the filter as well. So it's like sometimes you really want to know the subjectivity of it, and if you just say like, oh, I want it based on how I interpret it. But sometimes like coding, I want it based on how the ground truth interprets it. Right, so there are different spectrums of responses that you get that are suitable for the task. Some tasks you want it to be in your perspective because it's like maybe you are going through the environment, you want to know what's green to you, then that's perfectly fine. I respond in your kind of view. But sometimes it's best if I respond in the objective view because like talk about green light when driving, you need to know how green looks like to most people. You cannot know how green looks like to you only. So then in that task, yes, I need to tell you the objective truth. And I think in some sense, you can query it. You can say I want the objective truth or not. Yeah. The universal information database would be able, maybe we just call it universal database, right? The universal database would be able to view it in your view or view it in the ground truth view or map your view to ground truth view. That's perfectly fine also. Yeah. Because I believe that it's able to understand you and able to tell you what there is, like how different your view is to the ground truth. I think all these are perfectly possible things that you can expect from a universal database because the universal database has everything, has all information out there. It's able to tell you how you interpret versus what is the ground truth. Yeah. And
So if the universal database already has everything, then it already has the ground truth. So we can already tweak it based on a simple parameter like temperature. Like with LLMs, you can set the temperature and set how far it strays from the, I don't want to say ground truth, but like you know what I mean, like the objective best next token over and over and over again. You can play with the temperature and have it be more randomized, and that'll account for like answers that are further and further from the ground truth. Still grounded, obviously, but the randomization allows for it to stray from the ground truth a little bit. It allows you to kind of like expand your possible state space more, and you can have different states that you could explore, and account for things like different experiences, different perspective, stuff like that. I think what we're describing is kind of like a, I don't know if we're describing temperature or if we're describing a multimodal version of temperature. We might be describing a multimodal version of temperature because my understanding of temperature is that you're just controlling the token RNG. So essentially, if you have multimodal tokens, it's the same thing, except it's in a multimodal token space. Or could I think we could be talking about the latent space too. But again, that's a nuance.
Yeah, I do think this is probably ideal because the individual sometimes wants the ground truth. Sometimes they want based on the perspective of the individual, depends on the use case. So the universal database needs to be able to do both. And it could be just another filter to decide whether should I interpret based on your lens or interpret based on the objective lens. Very, very possible to do this. In fact, it could even be done in LLMs now. You could just say, I'm a pirate, interpret this in pirate style. Then they will dissect it, or like I'm a historian, reply in a style that's best suited for historians. Like you're able to cater for the audience type, the personality type, and give quite personal responses. And this means that like LLMs itself, just based on learning text online, it's able to sort of act as a universal database to switch between moods, switch between languages, switch between levels of understanding, like reply to me as a child, reply to me as a professor, or reply to me as a normal person, that those kind of things is already able to do, which kind of shows the potential that it can do if it once it's equipped with more sources like images, audio, videos. Like maybe if you upload your own memories to it, you can even learn a lot of things beyond what the individual can already understand. Yeah. And the beauty of this is that as the individual learns new databases, new knowledge, all these learnings can go back to the universal embeddings because what our universal database because the universal database only knows as much as what the individuals know, assuming that we don't give it system information. Essentially, it's a growing and learning database. It learns and grows based on what the individuals learn and grow. And as the individuals learn and grow even more, they learn more insights from this, which we will talk about it next week. How we get the insights, how do we do reflections from our observations, how do we do this? This is very, very important in AI because this affects how we learn new knowledge. How do we increase all this? And as the individual increases all this, I believe all this will go back to the universal database, and the universal database will get more and more aware of things that are happening. It'll be updated of the latest news, insights, because as individuals gain more things, this will be pumped to the universal database. Yeah. So, okay, essentially, universal database is like, I mean, talking about stuff like the Akashic records here, but you can also refer to LLMs because LLMs are trained on human data. Yeah. So this are one way to model universal database or universal information. The other way is internal memory, where our body has muscle memory, our mind maybe has episodic memory, has different ways to model, like or have different ways to remember what we have observed in the past. You can query that as well. And this database itself has the same biases as you because it's the way you represent the information, right? The information goes through you, is filtered by your lens, and then it's stored in your memory based on that filter. So that is easier to do the modeling because your internal memory will always be suited to your lens. Like how you view things will affect how your information is stored. And like in the future when you view things differently, maybe you can't query the memory again because like your understanding is so different, it doesn't make sense anymore. You need to gain new information to query that in your memory. Like so this whole thing here is a complicated affair. Like querying memory itself, I believe, uses the same lens as how you view things. But querying a universal database, that universal database will need to understand your lens and will need to understand the information of the entire world so as to cater back information for your lens. Or it can also give you the ground truth information based on what you need. And all this affects your individual learning. Individual learning, let me just go through some slides for next week. Individual learning, you can learn more and more information, you learn more and more filters. You this one we will talk about next week also, like how the universal database can even increase tokens or like even yourself. You can also form new tokens if the existing tokens are not enough to represent it. Yeah, so this is new knowledge synthesis and it happens at every level, individual level, group level, which is like the universal database. how do we share knowledge with one another and so on. Yep. So I will talk about all this next time. And I do think that learning from experience, consolidating new insights, and maybe you have a shared insights in some universal database. All this might be quite important to learn from the world because you are able to learn at your pace. Because everyone can only learn stuff that is like near the edge of their known knowledge. If you learn something too far off, it will just be an abstract symbol and you will have no idea how to represent it. You need to slowly push that known knowledge further and further up. And as you push that known knowledge further and further up, you can construct filters that are more suited to push that boundary. So as you learn more knowledge, you are able to learn even more knowledge. So that's the beauty of learning, you see. Like you will never be able to learn everything. But in order to learn something complex, you need to start from the simple and you push your boundaries all the way until you reach that complex knowledge. And I mean that's the beauty of how you use your intent to filter the world, how you learn from that, and how you refine your intent to filter some more. So just a brief heads up, I'll talk about some text-based RPG game where you learn information and you basically gain your knowledge, you're able to do more actions and you're able to explore more of the world until you solve the game. Yeah, so that's like a nice example of how you learn stuff and how you update your filters and so on. And if we can model this in a learning system, an AI system, you will get very adaptive AI systems that can learn from the experiences they have in the world and self-improve themselves. Yeah, so this is beyond just using some memory to choose from selected actions and so on. This is about using intent, query either the memory or query your present situation with your intent, getting that focused knowledge based on your intent and reflecting on it and gaining new knowledge. This is more than just rack memory retrieval. It is an intentional retrieval based on filters, and that filters are all learned using intent and using your knowledge base.
Can I chime in here?
Yes, please go ahead.
So your this intent thing remind me of I just want maybe if you can give a comparison of this intent with, if you look at the reasoning models, right? You can see in the reasoning trace, there'll be something like, oh, I think something, I'm curious about something, I wonder what, so let's explore those. So it seems that you can also interpret that as some kind of intent, right? Because the model is trying to decide what to do for the next step. So how would you compare these two?
The model is trying to choose an action, right? To think through what's the thoughts
Yes,
and then
yes,
choose an action.
yes.
Yeah, so I mean, if you treat thoughts as a way to decipher an intent, to like generate an intent, yes, that's like a pre-processing for the intent, but the intent is the action, right?
No, 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 no. They are using so the thought because you can equip those reasoning model with tools, right? So in a way, if you like you use those model, if the eventual decision of using certain tool is a result of this thinking, then you can argue that actually it used its intent to generate some action.
Oh yeah, that's a different I mean that is true. So I believe I'll be covering more about that in another set of slides. I believe that your intent drives your actions. Like you say I want to walk from point A to point B, then the next action might be to walk, like to move your left foot, right foot, that kind of thing. So essentially at a high level, intent or your goal will drive your actions. And this basically, I mean, if you treat this in terms of like large language model reasoning, you treat the whole reasoning step as an intent. I mean, that's a very that's not exactly intent. That's more like a way of thinking first before I get my intent, because they need to say that, oh, maybe I need to go out and throw the trash. That's the intent. Yeah, but before that, you have a whole reasoning step like saying, oh, there's a trash bag in my hand. I'm not near the rubbish bin. I need to go somewhere to throw the rubbish. So the intent is to go and move towards the rubbish bin. Yeah, so basically that whole process of thinking might just be to generate the intent, but it's not the intent itself. Then once
Sure,
you get, yeah,
that's just the model trying to justify its intent, right?
yeah, but this definition of intent is very important for downstream tasks because then it will be mapped to the actions. You don't want to give your whole reasoning process as your intent, then it's very hard to
That's
map.
not okay. I see. But I think my point is after the the reasoning process, then the model decide on doing something, take some action. Then I go and actually take the action. And notice that the user only asks a question without telling model to do any action. So the fact that the model decided to use some action is totally an intent of its own. So that's my point. The user did not imbue any intent to the model. That's why this has to be some kind of intent initiated by model itself, right?
Understand. Yeah, so there are many layers of intent, you see. Like intent at the top level can generate maybe the chain of thought tokens. Intent at the chain of thought level can generate your broad intent, like to move to the rubbish bin. Then intent at the action level can generate the motor actions. So at every level there might be an intent.
Yeah. But so do you agree that currently we already have the AI system that has intent? So it's
Yes,
not a very
yes.
far-fetched concept, and because I find that it already can be found in the current AI system.
Yes, we can use intent to drive actions using LLM-based goals and mapping into an action space. Like for example, you want to search the web, then you give your action space a web API search. Already I can map from my intent to search the web into a specific API call with search parameters. And this is an example of how you can use a universal or you use your own intent using your own filters and so on to get it grounded to some action space. And I believe we have already been able to do this.
Okay, and on the filter side, I think it's related to just now your question of whether the model should answer the question in the most objective manner or suit to your individual filter. I think in some sense, if you have a model that can reply you in a very personalized manner, then you can argue that's some sort of filter that cater to your the model general response cater to your filter because it's more effective that way and you can receive the information more effectively despite the fact it's still the same natural language, but the way it present the information or the knowledge is like, for me personally, I feel, oh, if you present this way, I can absorb the knowledge or can get the information more effectively, then that's like the model is presenting the knowledge according to my filter.
Indeed. And I do think that the universal information that exists like in reality, if you believe in the non-physical, I believe it's already attuned to your own filters and it's able to give you information that you need at a given point of time. Like so it's a bit hard to say because it's not science related. It's more like the science you see, the kind of insights you gain. Sometimes it's only given at the right time such that you can choose a particular course of action in your life. Like should I go for study in topic A or topic B? Sometimes your gut feel will tell you, hey, topic A. But how do you get that? You don't know. Like these are the intuition or something that yeah.
Yeah, I mean my comments are in the context of AI system or no. Yeah.
Yeah, so in AI systems, it is entirely possible if you already understand how the individual the individual's knowledge base and you can interpret their language based on their assumptions and beliefs. It is very possible to either give a response based on their assumptions and beliefs, or you can give the objective response which you don't even look at their ground truths
I noticed that in the example I gave, it's both subjective in the sense that the message is presented in a way the user individual can absorb more effectively, but at the same time, it does not compromise the objectivity of the information.
that's possible. Yes. So basically you selectively present objective information to the user.
Well, it's not even selective. It's like the way you present. It's like the message has essentially the same semantic meaning and contain the same information, but it's because it's personalized response. It just presented in a way that you as an individual is easier to absorb to get it. So that in a sense is also cater to your filter, right?
Yeah, that's actually a very good point. In fact, good teachers can do this. Like,
Yeah, same, exactly. I mean, very same, yeah, same energy. Yes, yes.
yeah, good teachers can cater to what you already know and build on that based
Yeah, but
on
it's not
the
like
building blocks.
the teacher compromise the knowledge itself, right? Yeah.
You're right, you're right. So the example I gave on the red-green colorblind was an extreme example whereby the knowledge is different from the ground truth. I mean, the assumption is different. Like I see green, but actually it's red. Here we are talking about I see green, and like based on this understanding of green, I can do green number one, green number two, like the deductions. And like basically the teacher knows that okay, you are aware of the color green. I give you green number one, green number two, which is similar to what I want to teach you anyway. The what I want to teach you maybe is like red number one, red number two, but
Yeah,
in
sure. I mean that's more like maybe more analogous to teaching students with certain they are lacking certain, okay, can be colorblind, or they are they have some defects in some ways. Then that's like that's definitely also another possibility. But I mean, I just trying to point out like there's also the case where you do not need to compromise the objective. Yeah.
yes, I like it. That's the best case actually. If you don't have to compromise the objective, but you can let people learn better using their filters to reply to them, that's the best case. Yeah, because you don't have to compromise and you don't have to compromise anything. In fact, you are making the process even more efficient.
Yeah. Okay. Then last point. This one is related to one of the example you gave earlier, which is use the calculator example, right? You can
Yes,
delegate the
yes,
task to a calculator, so you do not even need to know actually how to do the calculation or but I just want to clarify that uh so people have done experiment using, I think, reasoning model, or they have done a experiment on using a spectral model differing their capability, then ask them to do different level of calculations like multiplication or whatever with different level complexity. You can have very complicated multiplication, and what they find out is better model, their parental front, or the ceiling of their capability of doing the multiplication is higher compared to worse model. And for the same model, like they can do like the relative easier elementary level multiplication, almost perfect or even perfect. But as you increase the complexity, maybe like multiply numbers very many digits, you can see the performance degrade over like
Mhm.
as you have increased complexity, right? So okay, my point is this. Does the fact that they can't perfectly do the more complicated calculation an indication of their inability to understand what's multiplication? I would argue no, right? Because same happen to human. We understand how
yes,
it
yes.
works. It's just due to because we don't strictly operate as a calculator, right? So that's why we also make mistakes, especially for very complicated calculations. But it doesn't mean we cannot understand the essence or the mechanism or the rationales of what is multiplication and how to do it. So the fact that we rather delegate or the model, even like something model like O3, they rather just use code execution to calculate because it's more reliable, right? But
Yes.
they at the same time, it's not an indication of their inability of understanding the concept of multiplication, I would say.
You're right here. Your understanding of the concept and how you actually compute might be a different thing because like understanding the concept might be like you have perfect understanding, but once you actually implement it out, maybe due to some errors, like some you overlook something, you might still get the output wrong. So in that case, you are right. Yeah, I'm thinking that if a model is competent enough, is able to do like all the sub steps itself, you might not need a tool to do it, but you should still probably use a tool because it's more reliable. Yeah.
Yeah, same goes. You do a math exam. You after you complete everything, you want to do a run of check with calculators, right? Because yeah,
Yes.
we are not we can't do it guarantee with guarantee 100% time always correct.
But you also agree if you do it yourself, you will gain more insights into the process of doing it compared to offloading it to a calculator, because you know the inner steps compared to letting someone else do for you.
Sure, but how is it connected to the point you're trying to highlight just now?
Oh no, the point I was trying to highlight is that you learn different things based on different kind of like which pathway you learn from. Like if you learn doing it yourself based on your subtask and doing all the equations by yourself, you will gain more insights compared to, giving a tool. Then you only learn the superficial input-output relation.
Oh, okay. Like at learning stage, definitely. I agree. Yes.
Yeah, but you're talking about the concept part. I agree with you.
Okay.
You can get the concept right, but you can get the output wrong.
But I mean, it's not even just concept because they can do the easier one correct, which means it's not just about concept. Yeah.
That's right. All right. I think it's late already. We'll continue this great discussion next week. Thanks so much for chiming in. I think it's great. I'm still learning stuff. This is not a fixed theory. It will evolve according to our discussions. So looking forward to chat with you all next week. And see ya. Bye.